Okay, we're going to go into ionic equations and energy and reactions. Okay, with the ionic equations, we're going to actually be doing a lab that has a lot to do with this. And ionic equations are just taking two things and putting them together and then getting a net ionic equation. Let me explain. So say that we had sodium chloride, and we add that to silver nitrate. Through double displacement, we're going to end up with silver chloride and sodium nitrate. That's because everything in here has a +1 or a -1 charge. Now, as we look at this, NaCl is aqueous, AgNO3 is aqueous, AgCl is a solid, and NaNO3 is aqueous. Now anything that's aqueous I can break down into my ions. So I've got Na plus aqueous plus Cl minus aqueous, and any ion is aqueous, plus Ag plus aqueous plus NO3, and I'm trying to write small enough to get this all in, aqueous, gives me AgCl solid and Na plus aqueous plus NO3 minus aqueous. As we look at this side to side, we notice that there's some that don't change from side to side. For instance, sodium here is the same over here, and NO3 is the same over here. These are known as spectator ions. And that's because they don't change side to side. So spectator ions we drop out of a final net ionic equation. And I do this sort of backwards from what your book does. I don't like to write this out like this. I like to just say, oh, this is the thing that's different. It's a solid. So what things made up that solid? And I do it sort of backwards. I say, oh, AgCl is the solid. What ions made up AgCl? Well, Ag plus and Cl minus. And I know since they're ions, they're aqueous. That means everything else was a spectator. So I can look up here and say, oh, what did I not use in that blue equation? Well, I didn't use sodium and I didn't use nitrate. So those are my spectator ions. So basically, they just want you to know in this part of the chapter how to identify a net ionic, which this is down here, net ionic equation. And I'm not going to spend a lot of time on this in the video because we're going to do a whole bunch of these in class and do a lab with it. So we're going to have a net ionic equation, and we need to be able to identify what are my spectator ions, which ones will drop out and not be part of the real equation. So we'll do more of these in class, but it gives you an idea. Like I said, I don't use this equation right here. I don't set it up this way. You can, you don't have to. It just makes another extra step. Okay, so with energy and heat reaction, we're usually looking about where heat is. Is it on the reactant side or the product side? So if I have A plus B yields heat plus C plus D, you can see that heat is exiting the system. It's coming off of the system. And because of that, we get exothermic, thermic meaning heat, exo meaning exit, reaction. That's on the product side if the heat is on the product side. Now if heat is on the reactant side, if I have A plus B plus heat to make the reaction work to get C plus D, so I've got to heat it up or warm it up, then heat is entering the system, and because it's entering, it's in the first part, endothermic, again heat, entering the system, and that is on the reactant side. Now, they're not going to have you do much more than that I can see, other than know that heat can be labeled or put in as a number. For instance, it can be said like 570 kilojoules or 302 joules. So joules is usually a measure of heat or energy. So if you see that, that's heat, and just see where it is. If it's on the product side, you've got an exothermic reaction. That means it's going to feel warm and give off heat. Or if it's on the reactant side, it'll feel cold, like a cold pack, because it needs heat to react. And that was what you need to be able to identify. Other than that, I think we're good for these sections. So this was a real short one, but I'm sure you're not feeling bad about that. Next one will probably be a little bit long.